Hey guys, in this video we are dealing with quadratic equations. Now we are finally at the end. Hooray! We've been doing a lot of stuff now. And all honesty, the majority of the stuff we did with quadratics was pretty much a touch of a review from what you did in Algebra 1. Because in Algebra 1, you kind of touch on that a little bit. But here we kind of went into the details and touch on everything else, such as the graphs, its characteristics, and how the transformation affects the characteristics, which we should know. In most cases, it affects the intercepts and it deals with the range. Surprisingly, it never deals with the domain at all. Alright. Heads up. Watch out now. You got some things going on. Alright. The first thing that you have going on, y'all, is your direct test. The district want to give you guys a test on what you have learned so far. So this is what I'm gonna do for you guys. Show up and get yourself some free 50 points. And all thing you have to do is show up and take the test and do the best you can on it. If you can do those three things, you're gonna get 100. So for the test that they want you guys to take, it's not going to be really based on much of what I taught you guys, only because this is stuff from the previous semester. And for the majority of you guys, you were not in my class, and when I came into a stream, I came in so late in the year. So that's it. However, my test does count for a lot of points. So you're going to be spending about between 500 and close to 1,000 points. It's really serious. And then you have a project coming up, which I taught you the details. It's not hard at all. It's really just research. Because in my class, you will do some research. It's not bad. I promise you it won't be. Alright. For this lesson, you would need get your factoring skills together, solving equations, and quadratic function knowledge. Alright, so let's talk about factoring. We did the last class period, so let's talk about it. Well, the first order of business is that factor of 13, which of course we want 1 and 13, because that's what A is equal to 1. Remember? I'm sorry, I'm going a little ahead of myself. That's the standard form. So, a rolling factor pairs, so the questions remain, what two factors, when you multiply together, gives you 13, but when you add them together, gives you 14. I accidentally gave you the answer. So 1 plus 13 equals 14, because 1 times 3 is also 13. So, factor just like that, and that's it. Now, if I was going to check my work, going from factor form back to standard, I just have to use my foiling method, as you see here. When I fold these things around, remember, my first, my outer, my inner, and my last. So, This is your your first. This was your outer. This was your inner. And this was your last. Bam! Just like that. And after that, we get back to where we started from. Now, of course, I'll be testing you on that. All right. So how do we factor in this case? A is bigger than 1. Now, there was a method that I was supposed to have taught you, but for some reason, I don't want to because I feel that this would be easier. So look, let's look at the coefficients. You have a 2, a 7, and a 5. Do they have any greatest common great factors, forgive me, factors other than 1 in common? No, because 2 don't have nothing in common with 7 and 5. 7 do not have anything in common with 2 and 5. And 5 don't have nothing in common with 2 and 7. So, time for us to do that swing method. Well, before you can swing anything, you gotta multiply 2 times 5, which gives you 10. So we gotta rewrite it. D squared plus 7D plus 10. So looking at 10, my C, what two numbers when I multiply together gives me 10, but the same numbers when I add them together gives me 7. So 10 equals 5 times 2, and 5 plus 2 equals 7. So x plus 5, x plus 2. Now, usually, I personally don't too much care for order, but some mathematicians going to be kind of picky on it. So to do this more mathematically or orderly, take your smallest number, which was 2, and your bigger number, 5. So left to right. So remember, you start off with the 2, right? Divide everything by 2. So of course, 2 divided by 2, you get x plus 1. And then when you divide stuff by 5, you know you don't have a whole number when you divide, so you get 2x plus 5. And that should give you the correct answer. And bam. Oh, I'm sorry that I went from x to d. Let me apologize on that. I'm so used to d being x. I know that you guys going to do the same thing too. So let's fix that. So that was d here. That was d. That was d. That was d. So our answer is still correct from what we did because it's right here. So bam. The only thing that I did that was wrong was just the variable change. So keep in mind, guys, as you're working these problems, I know we always want to think of x, but wherever the variable is, you got to keep that variable. All right? All right. Remember how we did this one? So both perfect squares. So you got to write it like this. 5x, 5k minus 2, 5k plus 2. Of course, we factored this. Use our formula method. First, outer, inner, last. So let's do it. 5 times 5 is 25k squared. And what I'm doing now is just checking my work. Alright? Just checking it. So 5k times 2 is 10k. And then here I get negative 10k. And here negative 2 times positive 2 is negative 4. So things cancel out. I get 25k squared minus 4. And that is really how you get what we started off with. So this is good to go. Alright. The time has come for us to solve these equations, quadratic equations. So before I get into it, let's go back and touch on a basic equation. So these linear equations. So of course you gotta work with you gotta work farthest away from the x, because remember the goal is to solve for x, to get x. And to do that, that one that is away from the x, you make that be the opposite, subtract 1 from both sides, that becomes 6. Divide by 2, x equals 3. We know that. The box in the green, you're going to see that momentarily, because there's some additional information that was taught to you guys in Algebra 1, but I may have to call out to your attention. Well, I will later on in this lesson. Alright guys, let's solve this equation by factoring. Of course, we know this is standard form. But this time, since the equation you set to 0. Alright, so again, solve it as if you are factoring. Alright. So, when we factor, we know that we get x plus 2, x plus 3, simply because when you're doing stuff by 6, is 2 times 3 gives you 6, and 2 plus 3 gives you 5. So we know that part. Now, let me erase. Now, when you solve these equations, all you have to do is do this thing that we call set them to 0. To set to 0, you get x plus 2 equals 0. X plus 3 equals 0. Wait, Mr. Howard, why do you got two equations? I'm going to show you guys why. So, subtract 2 on both sides. You know that x equals negative 2. Subtract 3 on both sides here. X equals negative 3. Alright, so I solved the equation by factoring. Now, I'll just show you how to do it in decimals. So, when we say zeros, what we actually are saying is the x-intercept. That's what we are saying. So these two numbers you see here, when you look in decimals, guess what? Those intercepts, -3, -2, they end up matching our answer that we did. This, ladies and gentlemen, is a way of checking your work. So if I was to give you some equations to solve, you take it into decimals, punching in, it give you this parabola, which is the name of the shape of the graph. And from there, you describe everything. All right? Well, not describe in terms of characteristics of transformation, but when you graph it, you look for the x-intercepts, which is another way of saying zeros. And zeros are the answers to the quadratic. Again, anytime something crosses the x-axis, you call the x-intercept, that's going to be the answer of the equation that you solved by hand. Again, you show this in two ways. You solve the equation, then you use decimal to show to you in another way. So, let me show you this right quick. So look, the information in the green, all that's telling you is helping you describe which kind of solutions you will have. So the reason why we got two solutions is because when we factor, our stuff is greater than 0. That's why. Also, just looking at the graph itself tells you there's gives two solutions. All right. And again, this tells you where the graph has two x-intercepts, zeros are solutions. When you have one solution, 0 intercept, that means the graph only crosses the x-intercept once. And then when it doesn't touch us at all, you got imaginary numbers, which I'll talk to you guys about that momentarily. All right. So again, you see the stuff right here that just tells you. And I'm gonna explain this a bit further as we work along, because this really is going to help us when we're solving it for when we try to take square roots. Let's go ahead and move on. All right. This situation, solve for D. So I already got it set to 0, so we got to do it. So when D equals 0, well, that's just 0. Nothing else you can do there. So you notice that all the variables outside the parentheses, they're going to just go to 0. Now what's inside is when you got to solve for. So D plus 5 equals 0. When you solve for D equals -5. So it's going to be -5. I'm tripping. -5 and 0. And there you go. Again, putting it in decimals, looking for my x-intercepts. I got 0, as I told you, and -5, as I told you. Again, decimals is you putting in the graph. The graph is the answer. All right. So again, you're going to have to show me this in both ways, by hand and by decimals. All right. So let's solve this equation, which, guess what? It's no different from what we did before in the first one, except for it's already in factor form. So since it's in factor form, just set it to 0. All right. So x equals 4, x equals 2. And again, the information in the green is going to help us later on. And guess what? 2 is my answer, and 4 is my answer. Now you've seen it in two ways, graphically and with decimals. You guys are going to do the same thing. Solving the equation by the quadratic formula. Alright, now, you're going to forgive me, because now I'm going to sound like a weirdo. Like crazy weirdo. So, this was taught to you in Algebra 1, but in case you forgot it, maybe you won't forget it after I get through with it. I'll tell you. Because we got the variables of z, we're going to set this to z. I'm going to do it. So here goes. Z equals the opposite of b plus or minus square root b squared minus 4ac all over 2a. Z equals the opposite of b plus or minus square root b squared minus 4ac all over 2a. I'm sorry, y'all. I know you guys give me static, but that's how I remember it. So now I'm teaching it to you guys. Again, this was mentioned in Algebra 1, but in case you didn't see it in Algebra 1, it's okay because you're seeing it now. So, before I continue, let me pause here for a second. Let me address something. Remember, this is in standard form right here. So, ax squared plus bx plus c. So, pretty much just that. So, 4 is a, b is 8, c is 4. So that's what I want you to do. So they took the opposite of b, which was positive a, which became negative a because it became the opposite. And then for every letter you see, AC, you see A and C. So 4 and 4. And then B being 8. And that's just that. Now, the graphs you have seen, they give you two answers because of the curve for the graph having two intercepts. Remember, the quadratic function usually have two, normally have two intercepts, meaning two zeros or two answers. So let's finish up. Okay. So the 64 comes from all what I did here in the square root. All right. Again, all in the square root tells me. Then I go right there. That's cool too. And then 64 minus 64 is 0. So when I divide negative 8 divided by 8, what did I get? Again, remember I'm going to get two answers, plus and minus. Remember, never forget. Get two answers usually. So there we go. The square root of 0 is 0. And when we simplify all that, we get negative 1 twice. So negative 1. All right. and you see the graph. In this case, you see that I have one solution. Now, let me explain this about the quadratic formula. Paying attention to the discriminant. The discriminant is this part of the formula. So, if you got b squared minus 4ac greater than 0, we talking about the radical, you're going to have two answers. But if it's b squared minus 4ac and the radical equals 0, which that's what we got right there. Let me highlight it. You got 0 here. Because you have 0 in the square root, you end up having one answer. Now, at any time, you got a negative number here, anywhere a negative number, that means that it's less than 0 and it's not real, it's imaginary. Alright? And that is called the discriminant once more. And because the graph touches once right here, touches once, you have the answer of 1 and negative 1 and the discriminant being 0. Alright guys, let's go ahead and work this problem out. So, only thing you really gotta do is just go 0 divided by 2. 0 divided by 2, that's simply just 0, right? So, x squared equals 0, and the square root of it, because you gotta take the opposite, which is the square root, is just 0. So guess what? It's just that if you graph this in your decimals, I could guarantee you for a fact that you have just one answer. So you won't have 2, it's just going to be just 0, just 1. Now I'll explain momentarily, you're going to see the explanation of why. So guys, going back to solving those equations that I just did, remember about why that previous solution was 0? Why it was just 1, 0? Because look, when we solved it, it was literally just that. You just got 0. And so as a result, that's all. So I'm not going to do this problem for you because I want you to kind of think a little bit, kind of explore the situation. And your best resource of this is to use your decimals and this. Because as you're doing it, I want you to connect the decimals into this table. I want you to see the connections of why some graphs, when you graph them, they're going to give you one solution, or they're going to give you two real number solutions, so meaning that crosses the axis. And this is just me giving you whatever numbers. or imaginary means that they're not real. Alright, so again, I'm not doing that one. However, I will try one with you, a simple one, but I want you to try that one. So I'm going to give you something like this: x plus 1 equals 5. Well, let's subtract 1 from both sides. We get 4. And that's an x, so you have to forgive me about that. Well, we realize that I end up pretty much with a positive number, and when I take the square root that to undo it, I get something like this: x is equal to square root of 4, and because it's positive 4, you're going to get two solutions: 2, negative 2, positive 2, because this guy was positive. And to kind of see the connection again, I invite you to use decimals and stuff like that. And I'm not one to cover the details of that because that was already addressed in Algebra 1 for those who are a fast learner. But for those who require more detailed explanation, I could address it with you either in person or make a video to touch those questions. Again, I want you to do this one to see the connection with decimals, all this, all that. All right. I need for you guys to try this out. And remember, you could use decimals and again, use that green table that I showed you to explain why. So you would do that one. Again, use the decimal app. All right. You're going to still solve it like you would the equation, but I need for you to explain it along the way. And you could use your decimal app to help you. Same thing, you doing it, I'm not. And again, showing your work, using the graph to verify your answers. Same process again. Same stuff, except for here, you kind of have to think this one out. Now here, and some of the previous, you want to actually simplify the radical. Say, for example, if I do this one with you, how about that? I'm going to do this one for you because this is pretty important for you to deal with. So guys, this is negative 12. So when we solve it, of course, you get q equals the square root of negative 12. Okay, so here's the problem with that. For those who was with me, you know the issue. But for those who wasn't rocking with me, you can't have a negative square root. That can't never, ever, ever, ever happen. You can't have it because it's not real. So to do that, then negative, you're going to pull out outside the parentheses. So it's going to look like something like this. Now, you're going to have to break that square root of 12. So remember, going back to simplifying radicals, and when you look for perfect squares, when you break down that 12, you get 4 times 3. And the reason why I did it like that because I'm looking for two numbers when I multiply together gives me 12, but one of them I'm trying to find the perfect square of 4 is the perfect square because 2 times 2 is 4. And the square root of 4 is just 2. And then 3 stays inside because there's no numbers. Times itself gives you 3. So going back to that green table, you will see because there was a negative, you won't have no graph crossing that x-axis or giving you a 0 or a solution. All those things are all the same thing. It's not real, it's an imaginary solution. And this is how you write it. So you got to do that. All right. So this problem, I'm going to guide you on it just a little bit. The word and is just pretty much just saying x squared plus 3 equals 0. You treat that like a variable. Treat it like it's x. Again, since I wrote it for you, you gotta solve it and then go to decimals and graph the situation. Solving the equation. This equation, you gotta do it the same way. Except from here, you have to figure this part out. So I'm not doing this for you either. This is something for you to take care of. All right. So let's talk about. So D is pretty much saying x squared plus 88 equals 100. So you solve that and remember to simplify your radical. Say if I was to have 63, for example, as a radical. Well, I gotta simplify that. So I can simplify that to 6 times 9, right? 9 is a perfect square, so it's going to be 3 to the square root of 6. That's no number times itself gives you 6. All right. Now here, this is just going further with the decimal exploration. So for this problem, I'm actually asking you to do two things: to find out y-intercept of this, and to see if I have a real solution. If I do, cool. If not, just tell me why. And again, use your table, the little green table, going back to previous minutes ago. So if you haven't mastered that, again, go back to it to recall it. All right. But give me the y-intercept of the parabola and just see if I got a real solution or not. All right. Axis of symmetry. This is what I'm asking you for. Now, you guys gonna make fun of me a little bit because of the things I'm about to say and how they will sound. So guys, what I mean by the axis of symmetry, you given a parabola and then something on the tip, your x and your y, and this is called your vertex. And all I'm asking for And for the axis of symmetry, it's the x part of that tip, which is the vertex. I'm looking for x, only this guy. So when you graphing this into Desmos, you're looking for that graph where you get the tip from. And also, I'm going to be asking you to see, do I have any zeros? Zeros, accidents, helps, anything like that. If I do, cool. If I not, explain why. Green table will help. Alright, so I will system of equations. So, for this one, this is more Algebra 1, but if you could recall it. So, I want you guys to try this one out. And you tell me what's up. So, that's pretty much all I would recommend for anyone to do. But, say this for last. Say this for last. Alright? Don't do it like you do the rest of them. This be for last. If you had time to do it, cool. If not, save it. We could discuss it. Alright? What values of b does the equation bx 3x squared plus bx plus 12 have two distinct real solutions? So remember what it means to have real solution. That means that when you get to this part, that the square root is positive. Alright? And what you can do, if I were you, I'll check any of these out and just try them out for b and put them in decimals to find out. Again, you must explain why, and again, go back to the little green table to further assist you that I talked about earlier. Alright, here's a word problem for you to try out too. So a stuntman has jumped off a window for 100 feet above ground. For his safety, an air cushion of 26 feet wide by 30 feet long by 9 feet high is positioned above the ground under the window. So using a formula where h of 0 is the object of the initial height, how many seconds would the stuntman fall before he hit the ground, hit the cushion? Alright, when you get a chance, and remember, if not everything's done, you got homework to do. So for research, I need for you to go do as it says on the screen. Go to Google, research, answer questions, and then there's a link. And that's pretty much just all you have to do. But listen to me, guys. I will be sending you a blank slide of this for you to do as well. Alright? So you got the video of this and a blank slide. And again, work with someone, figure this out, because next class period is going to be our review, and then we're going to be tested from whatever, or we may get into something new while we're being tested or anything like that, and then we're just going to test. I will give you updated information on that. All right, thank you guys.